Good evening, everybody. My name is Ivania. I'm faculty here at the school. And we are part of the Global Change Ecology Lab. And for today, I need to talk about the work we do about how forests adapt to climate change. So we are particularly interested in forest dynamics. So we study all the components of the life stages of a tree, all the way from the seed production, reproduction, establishment, survival, and even all the way to the growth of adult trees. And what we want to do with this work is try to figure out, can we recreate this forest dynamic under the predictions that we have for these areas? So we have a set of climatic predictions, and we want to know what should we expect with these forests? Because we have done many different types of modeling work about how forests, how plants are going to be responding to climate change. And if you really believe in those predictions, they are telling us that this is going to look like Oklahoma right now by the end of this century. But is that true? Are these forests going to change so radically? Or there is a level of resilience of how these systems may respond to climate change? So if you think about how forests, and when I talk about forests, I mean tree species are going to be responding to climate change, how they are going to be adapting, there are two different types of responses. One has to do with adaptation, and in case there are some biologists here in this room, I don't mean evolutionary adaptation, I mean more acclimation, just to make it clear. So if you think about a particular population, a particular set of forests, like for example here in southern Michigan, what kind of plasticity, what kind of resilience do these forests have to cope with climate change? So to address that issue, what we have been doing is collect data all over Michigan in those demographic stages. And we are using that observational data together with statistical models to try to predict future dynamics. So usually what we do is to create these performance curves where we look at one particular stage, in this case, sylvan survival, and we have an idea of how sylvan survival responds to different environmental conditions. So here what we have is temperature. And what these curves are telling us is what it may happen in the near future. So those are the black symbols that we have here. The circle is the current condition, so this is the average sylvan survival. So across many years, where we have warm years, cold years, wet years, dry years, that's the average survival we will expect. But what happens if climate change? And that's what we have with the other two symbols. In a scenario one, which is a moderate scenario, versus a scenario two, which is a more extreme scenario. And as you can see here, things don't look good. We see how sylvan survival really decreases. So we can use these performance curves to start making predictions about what may happen in this forest. And because we have them, with different, for the different demographic stages, we may be able to reconstruct how these forests may change in the near future. The second way that forests may respond to climate change is by moving, migrating. So right now what we have is many tree species that grow here in southern Michigan but don't grow north. And that's because northern areas are too cold. The growing season is way too cold. But as global warming is progressing, these areas are going to be opening for these trees. And this is something that it has happened in the past. Vegetation has moved back and forth in response to climate. But what we have right now is climate change taking place at a rate that is way too fast for populations to move. As you can imagine, trees don't move very fast. So one idea that people have is, should we move in then? And that's what Mary Carroll just talked about assisted migration. Should we move in these trees around to prevent deforestation of these areas, or to just grow tree species that are going to be better adapted to the new conditions? And so what we have been doing is a series of translocation experiments where we have been working with species that only grow here in southern Michigan, and we have been moving them north. And we have been assessing not only how the local climate is going to be affecting them, but what is going to happen when they're embedded in the native community. Are they going to become competitors? Are herbivores going to target them? Do they find the right symbionts in the soil community? So now we can answer all those questions. And to finish, a little bit about teaching and engagement. I teach 3 classes. The first 2 are associated to forest ecosystems with the plants, classic, and forest ecology and management. But I also teach a class on analysis and modeling of ecological data, because it's not just about collecting data, but can we forecast future dynamics with that data. And with respect to engagement, I have two different projects. One is with Michaela Sint and her students. We have been creating curriculum for Ann Arbor school. So we have curriculum for 7th graders and another package for 9th graders. And what we are doing is to use our own research and embed it in their science curriculum so they can go through the whole scientific process. They come out with questions that are relevant for society, like for example, can we harvest cherries in the future? One of them. And then they are collecting the data that they need to be able to answer those questions, and they're also developing mathematical models to be able to forecast what it may happen in the future. The other set of engagement activities, this is now in the process of being organized together with Sheila Schuler. We are trying to work with colleagues at the DNR, the Department of Natural Resources, the Forest Service, and also the TNC, the Nature Conservancy. And the whole idea is, with respect to invasive species, can we bring science and management together? Can we have management informing the kind of science we should be doing? Can we, as scientists, bring in the scientific information that managers may need? So look out for this one because we'll be organizing it soon. Thank you.